Good evening. Last class we discussed the stem, its variations, etc. Today we are taking on a leaf. It is very essential organ of the plant. It is green color. It prepares food material, and here also in the leaf we have multiple variations are found that we can deal soon. Next, what is a leaf? So leaf is green, thin, dorsi-ventrally flattened lateral outgrowth borne at nodes of either stem or branch. So leaf is dorsally ventral flattened structure, and it bears axillary bud in its axis from which a branch or inflorescence develops. Leaves are originate exogenously. So the other day I told you already, the lateral roots develop endogenously from pericycle, whereas here the leaves develop from the superficial cells of the leaf stem, that is called origin is exogenous. The green leaves of the plant are collective called as foliage. Foliage is the collective name for all the leaves in a plant. The next, let us see the parts of the leaf. A typical leaf consists of the following parts: leaf base, petiole, lamina, stipules, etc. Here you can find the leaf base is the point of attachment of the leaf with this stem, and a stalk-like structure which connects the leaf base with the lamina is called the petiole, and flattened structure that is called lamina or leaf blade. The edge is called the margin. The edge is the margin, and the tip is called the leaf apex. So what is the leaf base? The part of the leaf which is attached to the stem is called the leaf base. So some modifications in the leaf base. Number one is the pulvinous leaf base. That is, the leaf base is swollen. The leaf is like this. This is swollen, and here you can find the leaves. This is called pulvinous leaf base. The second one is the sheathing leaf base. In a banana plant, where you can find the leaves are spirally arranged, compactly arranged one by one with the help of the leaf sheath. These are called the leaf sheath. You can find in banana and also in monocot plants. Next, petiole. I told you already, this is the stalk-like structure which connects the lamina to the stem. If a plant is having, if a leaf is having the petiole, that is called petiolate. Example, hibiscus. If there is no petiole, such leaves are called sessile leaves. Example, monocot plants, monocot leaves. The lamina, this is the dorsi-ventrally green flattened structure and having midrib and lateral veins and veinlets. And then the stipules, these are the lateral outgrowths of the leaf base. Example, hibiscus. So here at the leaf base you can find the green lateral outgrowths are found. These are called the stipules. When the leaf is having a stipule, that is a stipulate, and no stipule, exstipulate leaf. Next we have the functions of the leaf. So I gave a tabular form for this. The main functions and the specialized functions, those are called modified functions. Regarding the main functions, the first one is foremost one, that is very important, photosynthesis. The leaves carry photosynthesis and prepare food materials. Next is the gaseous exchange. You know the leaves are having minute openings, those are called stomata, through which the gaseous exchange takes place. The second one is the regulation of transpiration. The leaf also regulates transpiration, so it is also given a function, regulating the transpiration. These are the main functions of the leaf. Regarding the specialized functions, these functions also you can discuss later. One is some leaves used for climbing purpose, and some having protection, having spines and give protection. Some leaves storage, they store food materials and become succulent, and reduction of water loss by having a thick wall out it and having the spines, etc., to reduce the transpiration, and absorption of deficient nitrogen deficients. These are called the insectivorous plants. where the leaf is modified in such a way to trap the insects and getting the nutrients, the nitrogen materials. Regarding the vegetative propagation, some leaves are also called the reproductive leaves. They have some buds in their margins. Each bud is separated and develop into a new plant. These are the specialized modifications we will discuss at the end of the chapter. So other modifications that I told you, the small table is given, but again the detailed structures, the climbers climbing by tendrils, and the defense by spines etc. in Opensia and barberry plant, and storage is called by succulent plants, succulent leaves, aloe and garlic, and phyllodes reduce transpiration. The petiole or other parts may be modified into leaf-like structure. Acacia melanoxylon, Parkinsonia, and trap leaves, I told you already, absorption of nitrogen by insectivorous plants, and vegetative propagation by epiphyllous buds, the buds found on the leaves, example Rheophyllum and Scilla. Next, leaf venation. It's very important. The mode of arrangement of veins and veinlets in the lamina is called venation. It is of two types, reticulate venation and parallel venation. Reticulate means, reticulum means net-like structure. All the veins are arranged in a net-like structure, that is called reticulate, whereas they are arranged in parallel lines, that's called parallel venation. We will learn different types. So generally found in the dicot plants, the reticulate venation generally found in the dicot plants. There is a central strong midrib from which petiole is extended to apex, bearing smaller lateral veins from which veinlets and forming a net-like structure. Whereas generally here the parallel venation is found in monocot plants, veins of same size running parallel to one another from the central midrib. There is a central midrib. From the midrib, the lateral veins are arranged in a parallel way, that is called the parallel venation. Now let us see the reticulate venation. Reticulate venation, in this again divided into two types. One is pinnately reticulate venation, another is called the palmately reticulate venation. The pinna means feather, is also called unicostate. Such leaves are having only one midrib. There is a central midrib from which you can find the branches, veinlets develop and form a net-like structure, that is called pinnately reticulate venation. Example, mango and banyan. Whereas the palmately reticulate venation, that is called multicostate. If you remember this name, you can remember that many midribs are there. So many midribs, they will go either crossing the apex or going to different directions to the margin. So based on this, this palmately reticulate venation again divided into two types, convergent and divergent. The convergent, main veins meet at the leaf tip. At the leaf tip, all the number of these midribs go together and meet at the tip, that is called convergent. Or if they go to different directions in the leaf, this is called divergent. They are moving to different directions. Example, papaya, here you can find Gigifus. So here the diagrams are given. Here normal one, the pinnately reticulate venation, where you can find only one central midrib. From this you can find the lateral veins and veinlets, make it network. And regarding this palmately reticulate venation, you can find many midribs. Here you can find 1, 2, 3, 4, 5 midribs. Here you can have number of veins and they will go to different directions, that is called divergent, and all meet at the tip, it is called convergent. That's all. Next, parallel venation. The parallel venation, pinnately parallel, same, in the same way, there is a one central midrib, that is unicostate. From unicostate, from the central midrib, and these lateral veins are arranged in a parallel direction, parallel way. That is called the pinnately reticulate venation, you can find in banana. And palmately reticulation, many costate, so it's called multicostate condition. Many midribs. So many midribs go to different directions. Here also in the same way, all these midribs go parallel and meet at the top or at the tip of the leaf, that is called convergent, or if they go to different directions, that is called divergent. The convergent grasses you can see the photograph later, and divergent in Borasses or Palmyra tree. You can find this condition. Here you see the first one epinately parallel venation, the second one is convergent. They meet at the tip, and here they go to different direction. This is the Palmyra tree. These are the grasses. You can have this type of venation. And then why this venation? Why this venation? What is the function of these venations? So now let us see. The first one is the mechanical support. The second one conduct water and minerals and translocate the prepared food materials to different parts of the plant. And another very important thing is it forms as a skeleton and help in keeping the leaf blade rigid without folding, without cutting. This venation helps. So these four are the functions of the veins or functions of the venation. Functions of the venation or significance of the venation. So next we will go to this next chapter, the phyllotaxy. This is familiar to you, I think. This the mode of arrangement of leaves on the stem is known as phyllotaxy. It is of several types, and but the significance of phyllotaxy. Why different types of phyllotaxy are necessary for a plant? This is to prevent overshading, because if you in the same place you can find 4 or 5 leaves, one leaf by another leaf, the lower leaf may not get sufficient sunlight. But whereas they spread in different ways, so all the leaves will get the maximum sunlight. So that is the significance of this phyllotaxy. The phyllotaxy I told you already. The mode of arrangement of leaves on the stem is known as phyllotaxy. The main thing is it is useful to overcrowding the leaves and also to get maximum sunlight to all the leaves. Again, this phyllotaxy is divided into 4 types. First is the alternate phyllotaxy, second opposite phyllotaxy, ternate phyllotaxy, and whorled phyllotaxy. In the alternate phyllotaxy, one leaf at each node, and then they are spirally arranged on the stem. Spirally arranged on the stem so that they avoid the overshading. So again, this alternate phyllotaxy may be classified into different types. The distichous leaves, all the leaves are arranged in 2 rows that you can find Vanda and Ravenella. Tristichous, 3 rows you can find in Cyperaceae family, and Pentastechous, 5 rows of leaves. If you happen to see from the top, you can see 5 rows, Banyan. Octastechous, 8 rows in Carica, that is Papali. There you can find these types of leaves, but at each node you can find only 1 leaf. The second one, opposite phyllotaxy, where at each node you can find 2 leaves. Among the 2 leaves, these 2 leaves arranged in 2 rows, that is 2 rows, are successive nodes lie in the same direction, that is called superposed. Opposite leaves but arranged in 2 rows only. Those are considered in Goa, that is in Koya. The second one, decussate, that is opposite decussate. The leaves, opposite leaves and lower node leaves are at right angles to the upper node leaves. Leaves of successive nodes are at right angles to the each one. That is called calotropis. Example you can see, the diagrams you can see later. And the ternate means the 3 leaves at each node, nerium, and sometimes more than 3 leaves, that is called whorled phyllotaxy. In Alamanda and Alsonia you can find more than 3 leaves. So here the photographs are given. The first time you can find in Polyalthia or Annona, where you can find at each node you can find 2 leaves. And regarding the opposite decussate, opposite superposed, here you can find in Goa or Koya, there you can find arranged in 2 rows and facing same direction. And here the lower node is at right angles to the upper node, that is called decussate, example calotropis. And in ternate, nerium, at each node you can find 3 leaves. Here you can find 4 leaves. This is whorled phyllotaxy, example Alamanda. Next, the types of leaves. Based on the lamina and also arrangement of the petiole, the leaves are of 2 types. One is called a simple leaf. There at the tip of the leaf, this at the tip of the petiole, you can find only 1 leaf. The 1 leaf may be entire or without incisions. Mango leaf is example for a simple leaf. The second, compound leaves. where the lamina with incision up to the midrib level and dividing the leaf into small fragments, so small leaflets. The leaflets without axillary buds. That is another important thing here you can find. Here you can find, this is the petiole where you can find the leaflets are found. Leaflets are found. These are small leaf-like structures. These are called the leaflets. And the leaflet and a branch difference is in their axils no axillary bud. Whereas in the normal leaves, in the axis of a simple leaf, you can find axillary bud. Whereas here, no axillary buds are found in the axis of these leaflets. Example, cassia. One example is given. But here in compound leaves, you have different types. We'll deal later. So here, compound leaves are of two types. One is called pinnately compound leaves. The name you remember, the pinnate and palmate. The pinna means just like a feather. You can find the leaflets arranged in on both sides. That is called a pinnately reticulate, pinnately compound leaf, pinnate compound leaf. Or if you find these leaflets are arranged just like the leaflet is like this, just like that is called palmately reticulate. Or this you can have this palmately reticulate venation. At the end of the petiole, you can find this is one leaf, this is another leaf, another leaf. These are the leaflets. Leaflets are found like this. This is called a palmate compound leaf. So pinnate compound leaves, the leaflets borne on the lateral sides of the common axis. Another palmate, the leaflets arise from the tip of the petiole and spread out the fingers like in a palm. That is palmately reticulate venation. The pinnately compound these leaves are again classified into the four types: unipinnate, bipinnate, tripinnate, decompound. Decompound, here you have D, decompound. So unipinnate, the leaflets are arranged in the primary pinna or primary petiole, on the first petiole. So this is the petiole. Now, like generally it is called in rachis in compound leaves. There you can find the leaflets are directly arranged. In this leaf, this is called the primary rachis. So the leaflets are arranged on the primary rachis, that is unipinnate. In this unipinnate, they again divided into two types, imparipinnate and peripinnate. So at the end you have a pair of leaves at the end, a pair of leaflets, peripinnate, or you can have an odd number, odd leaflet, it is called imparipinnate, that you can see later. And in bipinnate, the leaflets are found on the secondary rachis. So here you can have the primary rachis, secondary rachis, the leaflets are arranged on the secondary rachis. Secondary rachis. This is primary rachis, this is secondary rachis, that is bipinnate leaf. The tripinnate, there you can find tertiary, that is the third pinna, that is called a tertiary. This is primary, secondary, and there you can find, there only you can find the leaflets. So third pinna, that is called tertiary rachis. But as in a compound, this decompound leaf, what happened? More than 3 rachis, there you can find the leaflets. Example, coriander you can find, in tripinnate moringa, and in bipinnate acacia, imparipinnate neem, peripinnate tamarind. Here you can have the diagrams. So peripinnate at the end ends with 2 pair of leaves, peri, and odd leaf at the end, imparipinnate. And here the next one, bipinnate. This is the primary rachis. The leaflets are arranged on the secondary rachis. So it is bipinnate. And in the tripinnate, tertiary rachis, third rachis you can find, that is the third rachis, tertiary pinnate. So this is the primary pinnate, secondary and tertiary pinnate, there you can find the leaves. And a decompound, what happened here? Many rachis you can find, 4th, 5th, etc. There you can find the leaflets. This is called the decompound leaf. Next, the next branch, that is palmately reticulate. Palmately compound leaf. Palmately compound leaf. There the leaflets are arranged just like fingers in a palm. Here unifoliate. If there is one leaf, that is unifoliate. Example in citrus. Bifoliate, that is at the end of this at the end of this rachis, you can find only 2 leaves. 2 leaves are there, bifoliate. Example, Jornia biloba. And if you have 3, that is called trifoliate bean you can find. And you can find quadrifoliate, 4 leaflets, quadrifoliate. Multi, more than 3. So in a Gynandropsis you can find more than 5 or 6. And Manihot you can have some 6 to 8 leaflets you can find, that is multifoliate palmately compound leaf. Here the diagrams are given. The first one unifoliate citrus. Here you can have a winged petiole is there and 1 leaflet is there. In the second one bifoliate you can have 2 leaflets, and trifoliate you can have 3 foliates. 4 here quadrifoliate, and this is multifoliate, many leaflets are found. Next you see the leaf modifications. Other than photosynthesis, some leaves carry some special functions for which the leaf or its parts may modify in different way to do those things. The first modification by these are climbers. Leaf part is modified into climber. Sometimes the leaf effects is modified into a climber. Here you can find in gloriosa, the plant gloriosa. Gloriosa, there you can find the tip of the leaf is modified to a tendril for climbing purpose. This is the gloriosa plant. The leaflet, the terminal leaflets may be modified into tendrils. Suppose if you have a compound leaf, here you can have normal leaflets, and the terminal leaflets may be modified into tendril in Pisum. And the whole leaf is modified into tendril in Lathyrus. In Lathyrus what happened? The whole leaf is modified into tendril, whereas the stipules are modified into leaves. And petiole in the clematis. In the clematis leaf, what happened? The petiole is modified into a tendril. Here you can find the leaf. The petiole is modified into a tendril in the clematis. And in smilax, there you can find the stipules are modified to tendrils. These diagrams you can see. The stipules are modified. So in Pisum, the terminal leaflets are modified. Here you see in the Pisum, the terminal leaflets are modified into tendrils. And in Lathyrus, the whole leaf is modified to tendril, and the stipules are modified into the leaf-like structures. And in Clematis, the petiole is modified to tendril and help in climbing purpose. In Smilax, the stipules are modified here. The stipules are modified into tendrils and used for climbing purpose. And next is the leaf hooks. In some plants, for example begonia, the 3 terminal leaflets modified into hooks. Hooks are stiff, curved and claw-like structures, help the climbing purpose. You see in the plant, the leaflets are here and the terminal leaflets are modified into hook-like structures. A finger is shown to understand. The 3 hooks are modified. These leaflets are modified into hooks. Next, spines. See here, this is for protection and also sometimes to reduce the rate of transpiration. The sharp pointed spines which gives protection and also reduce transpiration. So the whole leaf is reduced into spines in Opuntia. Opuntia you can see, in this what happened? The stem is modified into a flat leaf-like structure and the leaves are modified into spines. Leaves are modified into spines. So example, Opuntia and cactus varieties. And sometimes leaf margin is modified into spines. The plant is Argemone mexicana. Here in this plant, the leaf margin is modified into spines. One for the protection from the grazing animals. The leaf margin is modified into spine. Here the whole leaf is modified into spines. Sometimes the stipules are modified into spines. In Gigifus, in plant, here you can have the stipules is modified into spines. Here you can find this is a spine. The stipule is modified into a spine. Here you can find spine. Here you can have another spine. The stipules are modified into spines. And whereas in yucca and also phaeonyx, etc., where you can find a leaf tip is modified into spine. Leaf tips are modified into spines. Sometimes margin is also here. You can find the spines. Next, succulent plants. Sometimes what happens, some leaves used to store food material in the form of mucilaginous structure and they become swollen. So this you can find in aloe vera, this called succulent leaves. So leaves are modified into a swollen structure to form to store food material, etc., and become bulky. Those are called succulents. The next one, phyllodes. Any part of the leaf other than the lamina modified into a flattened leaf-like structure to carry photosynthesis. Here one example, best example is given. This is Acacia melanoxylon. In this Acacia melanoxylon, it is a bipinnate compound leaf. Slowly, the petiole is modified into a broad leaf-like structure, and gradually these leaflets are reduced. In a young plant, you can find only the phyllodes are only found to reduce transpiration. These are all phyllodes in the young stage. Later they will become phyllodes. Here also you can see this is the phyllodes. At the end you can have a bicompound leaf. These are actually normal leaves. Later it will develop into modified leaf as phyllodes. Next. So before I told you, some leaves help in the vegetative reproduction. That is, the buds are developed on the margins of the leaf. See, example, bryophyllum. In this bryophyllum, in the margins you can have a number of buds. Here you can find a number of buds are here. They develop into new plants. So they will be removed from the leaf and develop into new plants. So these are called reproductive leaves, or these are used for vegetative propagation. Next, trap leaves, very interesting, the insectivorous plants. These plants used to catch the insects for their nitrogen requirement. So developed a poorly developed root system, because roots are not necessary for them, only for getting water only. Inhibiting nitrogen deficiency plants. Leaves modified into specialized structures to get the nourishments and the nitrogenous materials by trapping, digesting, absorbing insects. Some of them are, these are familiar examples given here, and later a new examples also given for you. One is a Drosera, another is Utricularia, third one Dionia, and fourth one Nepenthes. First let us see the Drosera plant. See, you look here, the leaves are just like a spoon-like. At the end of this, the margins are developed into a number of tentacles. You can find the red color tentacles. They have secreting glands are there, so that they will, what's called spine, that's called shine. They shine under the sun, so those are called sundew plants, looking like a dew. So spoon-shaped trap leaves with the snare insects with the sticky, sappy substance on the tentacles, and then enclosed in their leaves. When any animal or any insect come across, they will close and digest, and then they will open again. This you can find in sundew plant. Next you have Utricularia. This is a hydrophyte. You can find this plant in water, and aquatic plant with dissected leaves are modified into bladder. Dissected leaves, some leaves are useful for absorption of water, and some leaves are used to have a bladder like structure. You can find here also, you can have this, a transparent diagram is given, and where you can find a number of tentacles, and some tentacles are facing towards inside. So along with water, he sucks the insect, digest and send the remaining water. So absorbing water and minerals. So this is a bladderwort where the leaves are modified into bladders. So this is called bladderwort. Actually it is Utricularia. Plant name is Utricularia. The next one, Dionia, is an insecting plant. This is called Venus flytrap. Here you can find just the leaf is just like the center midrib, and both the sides just like a door, and in the margins you have a number of spines, pointed sharp spines with secreting glands are there. Any insect happen to just fly, they will catch and digest. Here you can find the first diagram. You can see the structure. In the margins you can find the spines. In the second one, it is closed, trapped already. Inside you can see the insect, small insect inside. After that, after digestion, it will open again. The next one is Nepenthes. It is familiar from you because you might have studied from this 8th standard. There you can find the leaves are modified into pitchers. Pitcher means a small jug-like structure, a jar-like structure. Every leaf is modified into a jar-like structure. So the lower portion, the petiole, is modified into a broad leaf-like structure, and the picture is developed from the lamina. Lamina is developed into a pitcher-like structure, and the tip is modified into a lid-like structure. And inside you can find a number of hairs are there, secreting hairs are there, they digest. There you can find proteolytic enzyme is there inside, and the rim around this you can find a colorful rim is there, and there is a cap is there. So most of the students do not know how the insect is catched, and some people used to tell as soon as the insect comes inside, because of the colorful lid or rim, the insects used to come. As soon as the insect enters it, the cap closes. That is wrong. That is not like that. There is no movement of the cap. So the insects are attracted by the bad smell by this bladder. What's called bladder, this Nepenthes pitcher. So as soon as insect enter into it, because of this fluid, digestive fluid, it is killed. And also the facing tentacles, small hair-like structures which are facing towards inside, so that the insect cannot come out. It is digested. It is digested. So I am provided with a row of nectar glands. And you see the wonderful diagram. There you can find the rim is there. Rim is having colors. LED is there. Inside you have this, what is called the digestive liquid is there. The next diagram you see, so the insect is entering into it because of the bad smell. Later it is digested. So for your understanding, I gave some more names of the insectivorous plants. One is called sun pitcher, Heliumphora, and trumpet pitcher, Sarracenia, and cobra lily, Darlingtonia, and water wheel plant, Aldrovanda. These are some other plants. You can, a number of plants you have, more than 50. So these are very important and interesting. I will also show these diagrams to you. See, the first one is called Heliumphora sun pitcher. Sun pitcher, just like any Nepenthes, but different is a small lid here. So it shows that there is no function of the lid. No function of the lid. Closing and opening of the lid is very not good, not correct. So here you can find a small lid. Any insect used to enter, it is digested. In Darlingtonia, just like looking like a cobra, Darlingtonia, this is a cobra. Any insect enter into it, it is digested. So it is called a cobra lily, Darlingtonia. The second one, Sarracenia, this is a trumpet fisher. There is a long trumpet-like, long pitcher-like structures. It is Sarracenia. Another is called Aldrovanda. This is a water plant, hydrophyte. Just like a wheel, you can see is a wheel. So this is a rings. This is a rotates. Because of the rotation, some insects used to come. So many adaptations are there, are special things to collect the insects and digest them. Thank you.